Huawei has introduced a new AI server, and our analysis indicates that it stands toe-to-toe with NVIDIA's latest offering. I have some significant insights to share regarding this. Today, our discussion goes beyond merely examining the improvements in GPU performance. Earlier, I brought up Google's TPU, which when integrated into a system of 9,200 TPUs, achieves a performance level that is 24 times greater than the top supercomputer in the United States. The emphasis here is not on the capabilities of a single chip alone. We need to look at how the entire system performs. The key point here is that despite numerous sanctions, China can still match NVIDIA's computing power. At the heart of this discussion is Huawei. They haven't just assembled something in a makeshift manner. Huawei has consistently shown its prowess in developing extensive networking systems. Today, I have prepared an in-depth analysis based on insights from SemiAnalysis. So, let's delve into it. First, let's take a look at what Huawei has done. You've probably heard of the Ascend 910, right? So, in response to NVIDIA's Hopper and Blackwell GPUs, Huawei launched the Ascend 910 AI processor. However, it didn't quite match the performance of NVIDIA's GPUs. There were various discussions, like how it was produced through SMIC, a Chinese foundry. People said China still had a long way to go, but that's not the point. This time, we are discussing an enormous AI server that has been constructed by interconnecting a total of 384 Ascend 910 processors. This AI server integrates the Grace CPU with NVIDIA's Blackwell system. It was recently released. When compared to NVIDIA's Grace Blackwell GPU, the GB200 NVL72, it's nearly on par. Huawei has designed the Ascend 910 AI processor. It's important to note that this is not just about a single chip. By linking these processors together, they have created a massive system. This system has successfully caught up with NVIDIA. It's not just about making one good chip. Why did companies like Broadcom become so successful? It's not just about custom chips. It's about integrating them with networking equipment. I often bring up Arista networks in this context. Running a massive large language model or artificial intelligence model on a single chip isn't practical. So multiple chips need to be connected to form a high-speed interconnected network system. Huawei, already proficient in this area, has developed a large-scale system that, despite its individual chips being less powerful than NVIDIA's, achieves comparable performance. This underscores the greater importance of the network over the individual chip. In examining the insights provided by SemiAnalysis, it becomes evident that Huawei's AI Cloud Matrix 384A has been meticulously compared to NVIDIA's GB200 and NVL70. And this comparison is not just superficial, but delves deeply into various aspects of performance and technological advancements. Naturally, they evaluated performance, energy efficiency, the number of transceivers per chip, and other metrics. But if you examine the details, you will see just how remarkable Huawei's technology truly is. Before diving deeper, I understand that many people in our country have negative feelings towards China. However, dismissing or underestimating the advancements in China's technology does not diminish its level of sophistication. We need to acknowledge and confront this reality. China has achieved significant progress in science and technology, particularly after deciding to directly compete with the US for global dominance. This is an objective observation and not about supporting China. Some people might call me a pro-Chinese or something, but that's not the case. I'm from Daeyeon-dong, Busan. It's not about that. What I am saying is that China's technology is really advanced. Although I do not support the subsidies and the unfair practices that are often linked to it, we must acknowledge the undeniable reality of the situation. So, the 384 system in question is equipped with Huawei's Ascend 910 chip, which is presumed to be fabricated using a 7nm process by the Chinese semiconductor company, SMIC. However, there's speculation that it might not have been manufactured by SMIC, but rather by TSMC. I'll delve into this further later on. Ultimately, AI servers such as Huawei's Cloud Matrix 384, similar to NVIDIA's, scale up by integrating multiple GPUs and interconnected pods within their architecture to enhance overall performance. Each of these systems incorporates high bandwidth memory, HBM, to guarantee that the system maintains a high bandwidth, which is crucial for the overall performance. And it is essential that the network communication speed between these racks remains extremely fast. Huawei asserts that they have successfully constructed this network in a remarkably efficient manner. Physically, when you examine it, you can see that it is composed of a total of 16 racks. There are 4 racks here, 4 over there, another 4 here, and 4 more here, totaling 16 racks. Next, there are 12 compute racks, each housing 32 GPUs. That's a significant amount packed in. You can think of the GPU as a core unit in this massive system. At the core, we have what is known as a switch rack. Its function is to manage communication between all these components. As we have discussed multiple times on Antimony, NVIDIA, after acquiring Mellanox, chose not to rely on a common standard for chip-to-chip communication, but instead developed their own proprietary NVLink system in collaboration with Mellanox, which enables various AI chips within the system to communicate at ultra-high speeds. Similarly, Huawei employs a technology they refer to as Cloud Link Interconnect, which facilitates ultra-fast data transmission within their systems. They have engineered their own proprietary networking or communication technology, which enables ultra-fast data exchange between chips. They compete with standards like NVIDIA's NVLink and InfiniBand. In this regard, they are quite similar. Liquid cooling, which is illustrated here, involves a direct-to-chip cooling method where the liquid is applied directly onto the chip to efficiently dissipate the generated heat. When Huawei implements this cooling technique, commonly known as water cooling, it is specifically referred to as liquid cooling, because processors generate significant heat in a confined space, and there are numerous chips involved. This leads to a significant amount of heat that must be dissipated quickly. Traditional air cooling, which uses fans to expel the heat, simply isn't sufficient for the amount of heat produced. So they use a method to quickly cool using liquid like oil. Huawei also uses this method. Blackwell is also adopting this method extensively now. So let's take a detailed look at the comparison chart organized by semi-analysis. In the first column, we have NVIDIA's GPU 200, and next to it we have Huawei. Let's start with the BF16 standard. How many teraflops can each achieve? This is for a single chip. NVIDIA's GPU 200 hits 2500. Huawei's is only a third of that. And then many people comment, China still has a long way to go. NVIDIA's GPU 200 has 192 gigabytes from Hynix. Huawei uses Samsung's HBM. Samsung supplied 128 gigabytes to China. Consequently, the HBM bandwidth has decreased in relation to this change. Even with an expansion, the fundamental unit remains small, which highlights a significant difference in scale. Instead of focusing solely on the chip unit at the top, let's consider the entire system as a whole, which is approximately 1/3 to 1/4 the size. It's not just about making more connections. Simply adding more doesn't mean better performance. We'll delve into the network topology in detail later, but for now, can data be directly transmitted between all the chips within each rack? Even with such a configuration, performance can still degrade. For example, the NV72 has 180 petaflops. This is about twice the performance. It connects far more chips. 12 chips versus 384 chips. You can also see that the HBM capacity is much higher. For HBM at the terabyte scale, it's 13.8 and 49.2. In essence, it's 2 to 3 times more. The HBM bandwidth will grow a lot. Scaling up will double it too. When constructing such a large-scale system, you might assume that individual chips could fall behind those of NVIDIA. You can't use TSMC's 4nm or 5nm chips. Instead, you have to use SMICs. Even if the US imposes sanctions on HBM, making it difficult to use, they can still build a system of this scale. That's the crucial point. However, the power consumption is nearly 4 times higher, increasing significantly. I'll address the energy aspect later. But it's worth noting that China isn't particularly concerned about energy consumption. Overall, the computing performance is twice that of NVIDIA. The memory capacity is 3 to 4 times greater. The memory bandwidth is also more than double. So you can run it just fine. Even if individual chips are restricted, if this system is built, it can still handle both training and inference. That's a fact, everyone. No matter how much power it uses, we often consider energy efficiency. But China does not really care about energy. In Western countries, there's talk about RE100 and such, but in China, power constraints aren't as severe as you might think. And they are ahead of everyone else in terms of eco-friendliness and renewable energy. Many stock investors visit our channel these days. You know a lot about renewable energy, right? China is leading, especially in solar energy. They are at the forefront. China's progress has cut costs a lot. This is a big challenge for American companies. So in China's case, we suffer from air pollution. There are many negative feelings about it. They are heavily reliant on coal, but they are also investing a lot in renewable energy. What you're observing here is China's electricity production, with the largest share coming from the coal sector. Coal is the primary source, followed closely by hydropower. From time to time, I show you examples like the Three Gorges Dam or other dam-related conflicts in China to illustrate that each country has its own standards and expectations when it comes to energy production. Coal is so dominant, and then there's hydropower. But next, they're doing really well with bioenergy, wind energy, and solar power is no joke either. Because they are so advanced in these areas, if you look at the data, they have added the capacity of the entire US power grid over the past decade. Do you see how steep that growth is? So instead of developing something for power efficiency or designing an efficient NPU, their approach is more like, hey, let's use a lot of power and just expand the system. Focus on expanding continuously. Build on a large scale to create a huge AI center. That's the main idea. If we look at the same thing in the US, you can see that the total energy has been stagnant. It's been stuck at 4,000 for a long time, very steadily. Meanwhile, gas and fossil energy usage is falling. At least nuclear energy is stable. But since the overall scale isn't increasing, energy efficiency is a recurring topic. This is true for all companies. However, it's different in China. In China, where the consumption of energy is steadily on the rise, the primary focus is more on achieving high performance rather than reducing energy usage. Consequently, Huawei is excelling in this regard. The situations in the United States and China are quite different. Recently, during a seminar, I encountered some fascinating news. It seems that TSMC is continuing to manufacture chips for Huawei. These are actually the Ascend 910B and 910C models. The Ascend 910C production surged by 2025. Although TSMC is still under sanctions, they are reportedly producing a substantial number of chips for China. From this perspective, we need to understand that while it seems like China is isolated, it still heavily relies on foreign countries. As you saw, even the Ascend 920C isn't entirely made in China. According to SemiAnalysis, HBM is primarily sourced from Samsung. In our country, it is provided, and before the sanctions, they secured 13 million HBM stacks. They likely stockpiled a substantial amount before HBM3 was released. They seem to use many SMIC wafers, but most of the time they use TSMC's 7nm process. The US government analyzed the 910B and 910C. Most of them use TSMC dies. Moreover, they use a lot of equipment that was brought in earlier, like ASML DUV machines and various Japanese equipment. China isn't entirely self-sufficient. They are still using a lot of older equipment and are partially sanctioned, so production is still feasible. Additionally, there are reports. They are importing HBM indirectly. Initially, before SK Hynix gained prominence with HBM3 and HBM3E, Samsung dominated the HBM market. Samsung was doing well with HBM2E2, so it's estimated that they have secured a significant amount. Additionally, Chinese companies like Changshin Memory and SMRC have been making notable progress. For instance, Changshin Memory is expected to release DDR5 within a year, and they are rapidly catching up with SK Hynix and Samsung in terms of technology. Although there are discussions about developing HBM within the next 2 to 3 years and they haven't secured it yet, it appears to be only a matter of time before they do. Whether there are sanctions or not, it's clear that given time, China will be able to produce it. Now let's turn our attention to Huawei, which has been a hot topic recently. There's been significant buzz around NVIDIA's Quantum InfiniBand. Networking equipment at its core is fundamentally about linking multiple GPU boards and racks in a manner that ensures seamless communication, allowing them to transfer data at incredibly high speeds. In the ongoing competition against NVLink and InfiniBand, Huawei has been making substantial investments in optical transceivers, with the aim of achieving rapid and efficient data transmission. Remember when Yu Sung-jun used to advertise ADSL and Megapass and we had brands like Durunet popping up everywhere? Back then, there was a lot of buzz about ultra-fast internet being installed right to your home. When we talk about optical communication, it involves optics and fiber optics all related to light. In contrast to copper wires, optical communication eliminates interference, allowing for faster data transfer. Huawei has used these technologies for their new system. They have developed a system that integrates a large number of optical transceivers for networking. Each chip is said to be equipped with 14 optical transceivers. Transceiver companies will likely earn more. This is due to high transceiver usage. The same applies to NVIDIA. So, when we talk about scale-out topology, it is often in the context of scaling up or increasing capacity. In AI systems, scaling up means boosting the performance of a single server, typically by enhancing its individual chips. This concept is similar to how we discuss scaling up AI models and adhering to scaling laws. Scaling generally refers to increasing size, but when we mention scale out, it specifically means adding multiple servers horizontally and in parallel, thereby expanding the overall system's processing capacity. In the case of NVIDIA's NVLink, it creates an all-to-all topology where each component can communicate with every other component. Network topology refers to the structure that determines how multiple chips communicate with each other. Huawei meticulously follows this principle, ensuring that even if an AI model is distributed across various GPUs and servers within a rack, they can still communicate quickly and efficiently. This capability allows for the effective processing of large-scale models, showcasing high performance. In summary, The NVGB200 achieves an internal data transfer rate of 1.8 terabytes per second using NVLink Gen 5. In a rack, multiplying by 72 gives 132. The exact details are still unknown. For external communication, using InfiniBand or Ethernet can reach 800 gigabits or even 1,600 gigabits. Huawei is estimated to be at the 800 gigabit level with Ethernet, but this could scale up further. Let's talk about the P-tree method separately. It is similar to all-to-all communication. Each indicator communicates widely with others. However, the power consumption is slightly higher. Given that the manufacturing process is at the 7 nanometer level, it requires much more power than NVIDIA's GB200. As I mentioned earlier, routing back and forth uses a lot of power. This is more than for individual logic or SL calculations within the chip. So this system would use significantly more power for routing. But what did I mention earlier? China doesn't really care much about energy consumption. So when we look at companies like NVIDIA and Huawei, we see that they're not just making AI chips. While they do possess AI chips, having a single AI chip is simply not sufficient to manage the demands of recent models like DeepSeek or Llama 4. Therefore, they need to determine how to configure the network topology in such a way that everything operates smoothly and efficiently. They start by designing a chip, then move on to a superchip, connect these into supernodes, and finally link these nodes together on a large scale. A company that can successfully figure out how to structure this type of communication network can build a robust AI infrastructure. In this context, it is evident that Huawei is performing exceptionally well. Specifically, in the realm of network technology, Huawei has consistently remained at the forefront. Before the Trump administration imposed sanctions on Huawei, and even after, Huawei has consistently held a significant market share. Originally, Huawei's technologies, including network equipment like 5G, were widely adopted. So even with heavy traffic, they possess the technology to manage it reliably. You know, the often mentioned optical transmission equipment. In this field, Huawei is always competing for the top spot. Therefore, it would be unwise to simply dismiss this as mere imitation. In the memory business, our country has traditionally excelled, creating a significant gap with China. But when it comes to building AI data centers and servers, Huawei has always been a leader in this field. This might be the first instance where I am mentioning Broadcom on this YouTube channel. When people inquire about how Broadcom excels in both networking and custom chip design, I have previously discussed SerDes in this content. SerDes, short for serializer/deserializer, is something Huawei also designs very well. For more comprehensive details, you can watch this content to gain insight into SerDes, which is essentially a crucial technology for enabling fast data transmission. Huawei has also been good at this, and they have the potential to catch up quickly as this era unfolds. In the end, Huawei continues to demonstrate its technological strength by creating highly practical products while navigating around US sanctions. It is crucial for us to acknowledge and understand the areas where China excels in science and technology. Recognizing these facts enables us, for instance, in our country, to formulate policies that can significantly enhance our own capabilities in these technological areas. Whenever I create content like this, some people think I'm praising China, but that's not the case. I'm just presenting the facts as they are. It's important for us to understand this so we can effectively respond in areas where others excel. I'm explaining the tech trends between the US and China. Please don't take it emotionally. I don't particularly like China either. That's not what this is about, so I hope you don't misunderstand and give it a listen. This has been Elho.